Objective 3, organize continuous data in tables. When a data set consists of a large number of different discrete data values, or when a data set consists of continuous data, create classes by using intervals of numbers. The table below here is a typical frequency distribution created from continuous data. The data represent the number of U.S. residents ages 25 to 74 who had a bachelor's degree or higher in 2016. Now, notice that the data are categorized or grouped by intervals of numbers. Each interval represents a class. For example, the first class is 25 to 34-year-old U.S. residents who have a bachelor's degree or higher. We read this interval as follows. The number of U.S. residents ages 25 to 34 with a bachelor's degree or higher was 16,206,000 in 2016. Now, if you notice here that there are 5 classes, okay, so we have 5 classes here, so let's go ahead and check mark those. So we have 1, 2, 3, 4, 5 classes, okay, each with a lower class limit. So with a lower class limit is the smallest value within the class. So 25 is considered a lowest class limit, 35, 45, 55, and 65. Those are the lower class limits. And then we have an upper class limit, which is the largest value within the class. So therefore 34, 44, 54, 64, and 74 are considered the upper class limits. Now the lower class limit for the first class in this table, as you saw, is 25. And then we said that the upper class limit is 34. Okay, and then we also have the class width. Okay, and the class width is a difference between consecutive lower class limits. So in the table, we can see here that if we take the difference between 35 and 25, so 35 minus 25 is going to equal 10. If we did that the same thing with 45 minus 35, it's also going to give us 10. So the data in a table are considered continuous. So the class from 25 to 34 actually represents all the numbers between 25 and 34.99999, or 25 up to every value that's less than 35. Now notice that the classes in a table do not overlap. This is necessary to avoid confusion as to which class a data value belongs. Notice also that the class widths are equal for all classes. So the class width is all 10. Okay? Let's take a look at another table here. Now, one exception to the requirement of equal class widths occurs in open-ended tables. So a table, okay, is an open-ended table if the first class has no lower class limit or the last class has no upper class limit. So the data in the table to the left here represent the number of births to unmarried mothers in 2015 in the United States. The last class in the table is 45 and older, which is considered open-ended. So therefore, the 45 and older is considered the open-ended. Again, open-ended class. So that's the class at 40 and older. Okay, let's move on to the next example. Okay, the example states that organizing continuous data into a frequency and relative frequency distribution. Now, suppose you are considering investing in a Roth IRA. You collect the data in the table below, which represent the 5-year rate of return in percent adjusted for sales charges. Now, for a simple random sample of 40 large blend mutual funds. Now, we want to construct a frequency and relative frequency distribution of the data. So here is our data, okay? And so what we want to do is we want to be able to first, we're going to construct this frequency distribution. We're going to create classes of equal length. So the table has 40 observations that range from Well, the lowest value that we have is 8.28. Okay, and then the largest value that we have is 19.43. So we decide to create the classes such that the lower class limit of the first class is going to be 8, since it's going to be a little smaller than the smallest data value. And the class width is 1. So we're going to make the class width 1. Now, there is nothing magical about the choice of 1 as a class width. We're just choosing it to be 1. Now, we could have selected a class width of 2 or 3 or any other class width, although some class widths are better than others. Now, we're going to choose a class width that you think will summarize the data nicely. So the second class has a lower class limit of 8 plus 1, which is equal to 9. So let's just take a look at this right here. Okay, so in our first step, okay, we're going to make the lower class limit equal 8. So the lower class limit is 8. Okay, and then if we add 1 to that 8, well then what that's going to do is that's going to give us 9. So if you notice here, our lower class limits from 8 and then 9, we can see that there's a difference of 1. Okay, and then what we're going to do is, again, here is the lower class limit, and then now we're going to make the upper limit 8.99, since that's real close to the lower class limit of 9. And then the next lower class limit is going to be 9.9. So I want you to notice here that there's a difference between the lower class limit. So 9 minus 8 is 1, right? And then 9.99 minus 8.9 is also 1. So the class width is going to be 1. Okay, and then the next thing that we're going to do is now we're going to tally. Okay, so we're going to find out all the numbers that are in between the classes between 8 and 8.99. So again, we're continuing this fashion. We obtain the following classes. You're going to see the classes. Okay. And then we're going to tally. So between 8 and 8.99, okay, so far we have one that's in between there. And then here's the second one. So we end up having 2 of them. Okay, so therefore our frequency is 2. And so our relative frequency is going to be 2. And we're going to divide it by the number 40 to get 0.05. Okay. So we can see that's what happens there. Okay, now I'm going to go ahead and erase that since we already have that written in there. Okay, now likewise, we want to find values that are in between 9 and 9.99. So if we take a look up here, we have 9.94 and 9.03. So those represent 2, and therefore 2 divided by 40 is going to give us 0.05. Okay, so again, we tally the number of observations in each class, we count the tallies, and then we create the frequency distribution. And then from there, we're going to divide the frequency of each class by the number of observations to obtain the relative frequency. Okay, so we're going to tally the data in a table as shown in the second column. Okay, and then the third column again shows the frequency of each class. And then from the frequency distribution, we conclude that a 5-year rate of return between 13% and 13.99% occurs with the most frequency. Now we'll go ahead and see that. So let's take a look at the next one here. Okay, our next class, again, we're going to add 1 to the 9 and 1 to the 9.9. So now it's between 10 and 10.99. So let's take a look at our table. So we have 1, we have 2, and then we have 3. And do we have anything else? And then there's our 4th. So we tallied 4 of them. So you can see we tallied 4 of them. So we get 4 as a frequency. And 4 divided by 40 gives us 0.10. Okay, let's move on to the next one. Okay, now it's going to be in between 11 and 11.99. So if we take a look at our values up here, and if we look at all of them, it looks like we're only going to be able to find one value here at 11.93, and there's nothing else. So we have 1 of them. So the frequency is 1. And 1 divided by 40 is going to give us 0.025. Okay, let's go down to the next one. Okay, now we're going to go between 12 and 12.99. So between 12 and 12.99, okay, we have 1, we have 2, and then we have 3, 4, 5, and then 6. So you can see we tallied 6, and 6 divided by 40 is equal to 0.15. Okay, the next class limit is 13 to 13.99. So let's take a look at that. So we have 1, we have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then 13. So we tallied 13, so we got 13 as the frequency, and 13 divided by 40 gives us 0.325. Okay, let's go a little further. Okay, now we're going to go between 14 and 14.99. So we have 1, 2, 3, 4, 5, 6, and then there's 7. So therefore we have 7 of them, and 7 divided by 40 is equal to 0.175. Okay, let's go to 15 and 15.99. So we have 1, we have 2, and then we have 3. So therefore 3 divided by 40 is going to give us 0.075. Okay, and then 16 to 16.99. Well, we have 1 of them. So 1 divided by 40 is going to give us 0.025. Okay, and then we're going to go down to the following. Okay, we're going to keep going down here to 17 to 17.99. And if you notice here, we don't have any of those numbers, so it's 0, and 0 divided by 40 is equal to 0. Likewise, 18 to 18.99, we don't have any of those numbers up here, so that's going to give us 0. And 0 divided by 40 is going to give us 0. And then if we look, there's one more number left between 19 and 19.99, which is 19.43, which means we have 1, and therefore we have 1 as the frequency, and 1 divided by 40 equals 0.025. So that means we're going to stop here. So we end up having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 classes with a width of 1. And then here's our frequency, and here's our relative frequency. Now, again, we tally the data in the table as shown in the second column. We know the third column shows the frequency, and the frequency distribution, we can conclude that a 5-year rate of return, okay, between 13% and 13.99%, which is right here, okay? So what we're saying here is that between 13 and 13.99%, we can see that it has the most frequency, okay, which means that we have 13, okay? So the fourth column shows the relative frequency of each class. So we can see here that 0.325 is the same thing as 32.5% of the large blend mutual funds that had a 5-year return of between 13 and 13.99%. Now, one mutual fund had a 5-year rate of return between 19% and 19.99%. So if we take a look, what was the one in between 19 and 19? That's over here, and we know we end up getting 1. So that percent was about 2.5%. Now, we might consider this mutual fund worthy of our investment. This type of information would be more difficult to obtain from the raw data. Okay, now let's go ahead and use Statcrunch. Okay, so all this data here that we have in a table, we're going to have to manually put that in. So our instructions are going to be the following. Okay, so for the frequency and relative frequency tables, we're going to enter the raw data into the spreadsheet, and then we're going to name the column. So we're going to go ahead and do that. So here is all the information in the column, and there is the return. Okay, and then we want to be able to create another column. Okay, and what this column we want to name this column, and we can call this, let's say bin. Okay, we'll just call it bin. Okay, since that's what we're going to use. So the first thing we want to do is we're going to go to data. Okay, and then we're going to go ahead and then highlight bin. Okay, and then we're going to select the column. So it's going to be return. Okay, and we're going to use a fixed width bin because of the fact that what we did here, we started at a value of 8, the one that we did manually, okay, because that's what we start at 8. And then we're going to make the bin width 1. Okay, so we're going to make the bin width 1. So therefore, all those values between, let's say, 10 and 10.99 are going to fall within that particular category. So now we're going to go ahead and select compute. Okay, now I'm going to go ahead and delete this column because it's already created a new column. And this new column now is called bin return. Okay, so we need to have this new column in order for us to be able to then create our frequency distribution and our relative frequency distribution. Okay, so now what we're going to do is we're going to go to stat, and then from stat we're going to go down to tables, and then from tables we're going to select frequency. Okay, now the column that we want to select is the new column that we just created, which is the bin return. Okay, and then what we want to do is we're going to highlight both the frequency and the relative frequency. Okay, and then we can just leave it as it is for everything else, and then we're going to select compute. Okay, and then here we can see that we have our bins going from 8 to 9, 9 to 10, and so on. Okay, now let's take a look at this. Okay, and if we take a look at this, you're going to see that the classes look a little different the way they're numbered, but the way we did the bin, okay, because we start at 8, right? You can see here that the values between 8 to 9, we have 2. The values between 9 and 10, which is the same thing as 9 to 9.99, is 2. And then the values from 10 to 10.99 is 4. So you can see how this matches our particular one that we did over here by hand. So it's really important to, again, go back to that, to the way we set this up, right? When we came in to set this up to create our new column, again, the important thing was to go to data, okay, and then to go to bin, and then we're using the fixed widths to start at 8 with a bin width of 1, and that allowed us to be able to then go from 8 to 8.99 and 9 to 9.99.